Hey everybody, today we're going to be taking a look at adding and subtracting radicals. So we're going to continue our work with square roots and how to deal with them as we progress forward. You're going to need your notes, a calculator, and something to write with, of course. So we need to remember that square root expressions with the same radicand are examples of what are called like radicals. So we're going to try to make things into like terms. So for example, this little chart here kind of illustrates what I'm talking about. You don't need to write this part down, but please watch. Like radicals have the same radicand. Like square root of 5 here, square root of 5, they both have a 5 as the radicand, the number underneath the square root, so they are considered alike. Both have x, both have 4t as radicands, they are considered alike. If those two do not match, they are not considered alike, and we cannot add or subtract them. So adding and subtracting radicals is basically done using the distributive property to show how it's done, but you can also just kind of read the problem and understand why we're getting these solutions. Let's say if we add, what if it's 2 square roots of 5 plus 4 square roots of 5? Well, you could just add the 2 and the 4, and that becomes 6 square roots of 5. It's like the square root of 5 is almost like an x was to us in Algebra 1. And the same deal with subtraction. 6 square roots of x minus 2 square roots of x makes, well, 4 square roots of x. So we're going to be trying to make like radicals happen for us, and then we can add and subtract things. So we're going to be trying to get similar or like terms to be similar to what we remember from Algebra 1. We're going to make those radicals alike before we can add them together. So understand the basic idea of what like terms are. 3 crayons plus 2 crayons makes 5 crayons. 3 apples plus 2 oranges I cannot combine to make anything as a sum because they're two different things, okay? So here's the first one in our example. Adding, subtracting, simplifying, whatever we need to do here. Let's take a look. It says I have 7 square roots of 6 plus 2 square roots of 6. Well, I notice that the radical expression here, or the radicand underneath the radical sign there, is 6. They're both the same. So 7 square roots of 6 plus 2 square roots of 6 makes 9 square roots of 6. Done. How many square roots of 6 do I have? 9 of them. 7 of them plus 2 of them makes 9 of them. Okay, let's look at another example here. What about if there's subtraction? 3 square roots of 6 minus 4 square roots of 6. Well, 3 minus 4 would be negative 1. So you could say negative 1 square roots of 6. Or if you don't want to put the 1 in front there, just like when we had 1x, we sometimes didn't write the 1 there, you could just say negative square root of 6. Either or, okay? Simplified answer. Negative 1 square root of 6 or negative square roots of 6. Well, what happens when I read the problem and it doesn't flow like that? It's not the same. It's not already alike. How do we get them to be alike? Negative 2 square roots of 3 plus 3 square roots of 27. Well, those radicands right here are not matching. So I can't add them together the way they are right now. They're not considered like terms. So what I need to do is simplify my radicals. This is why we spent so much time simplifying them. If I look underneath the radical sign here, this 3 cannot be simplified or broken down anymore. This remains negative 2 square root of 3. I can't do anything with that. Okay, but what about the 3 square root of 27? Well, remember that the square root of 27 can be broken apart. 9 times 3 makes 27, and 9 is a perfect square number. So if I simplify that, it becomes 3. If I square root 3, it's not really going to work, so square root of 3. And now if I drop down the 3 that was originally in front, remember what we do with those, that's 3 times 3, this makes 9 square roots of 3. So if I drop down the rest of the problem here, put my plus sign back in, put the negative 2 square roots of 3 in front, now by simplifying, I have made like terms. Negative 2 square roots of 3 plus 9 square roots of 3 makes 7, ooh, a little crazy there, 7 square roots of 3. So 7 square root of 3 is my final simplified answer. Okay, let's do another one. Here's another one where my radicals are not matching up here. Okay, my radicand number is square root of 12 here, and a 3, not so much. But I need to simplify before I go forward. So square root of 12 can be broken apart. What times what makes 12? One of them has to be a perfect square. How about 4? 4 times 3. So the square root of 4 is 2. The square root of 3 is something I don't know. And so I'm going to drop down that negative. Voila. There he is. So negative 2 square roots of 3 is what that beginning part simplifies down to make. I'm going to drop down the plus sign, drop down the rest of the problem. And now look, by simplifying that, I have created like terms. Negative 2 square roots of 3 plus 3 square roots of 3 makes 1 square root of 3. Or you can just say square root of 3 if you want to. Okay? So final simplification here, we need to make sure that we make like terms. Here's the last one. Got to make it a tough one, you know. So we're going to add, subtract, and simplify, whatever we need to do. We have 3 parts to this problem here. So 3 things to think about. We have a 3 square root of 18, a 3 square root of 12, and a 2 square root of 27. So it looks like none of those are alike right now. I'm going to need to simplify each and every one of them first. So let's start with 18. 18 can be broken apart into, that's right, 9 times 2. I knew you were thinking that. So the square root of 9 is 3. The square root of 2 is irrational, so I'll leave him. Drop down the 3 that was already in front. Don't forget that thing, okay? And 9 is what I get when I multiply, so 9 square root of 2. Okay, we're going to look at the square root of 12 now. On to the next one. What about the square root of 12? Well, the square root of 12 is 4 times 3. And the square root of 4 is 2. Square root of 3 is, again, that irrational part. And then we'll drop down the 3 that was originally in front. That's 3 times 2. So that's 6 square roots of 3. And then I'm going to do the 27. Okay, 27. 9 times 3. 9's a perfect square. So the square root of 9 becomes 3. The square root of 3 is something I leave. And then the 2 plops down in front here, making 2 times 3, 6 square roots of 3. So I'm going to drop down my signs here. They were addition. I was supposed to add all these pieces together. And now if I look through my list of things I'm supposed to do, 9 square roots of 2 plus 6 square roots of 3 plus 6 square roots of 3. The only 2 that are considered like terms are these 2, because they both have a 3 as the radicand, okay? So square root of 3, square root of 3, I can add those. It becomes 12 square roots of 3 in total. And that 9 square root of 2, I can't add that to the other piece, so I'm just going to leave him. Final answer is 9 square roots of 2 plus 12 square roots of 3. Done. That's as simplified as it gets. Okay, it's like when we leave our answers as 2x plus 3. We can't combine those things. We just have to leave them alone. Okay? So we're looking to try to make like radicals so that we can add or subtract whenever we need to. So we're using that simplification to find our final solution or our final simplified values. Okay? So thank you for taking good notes. We'll get some more practice on this in days to come.